every cubic metre of water weighs a tonne, and that tonne of water has a lot of energy within it. You can see it every time there's a storm, as the waves hit our coastline, and as the tides go in and out every day. So in those areas where we have fast-flowing water or large wave climates, we can extract some of that energy to generate electricity. We can generate easily 15% of the UK's electricity from wave and tidal sources. But one of the problems that we have at the moment, we're very careful that in trying to work to avoiding climate change impacts, we don't create any other impacts on our environment. So one of my colleagues, Dr. Ian Horsfall, is a fish biologist, and he's looking at where fish are, how they move around our coastlines, so we can then understand how the animals and creatures in that environment respond.
My particular interest is looking at the environment around tidal stream turbines, fast current sites, and looking at the kind of things that live there. Fast current sites are quite unusual environments. One of the particular problems is that they are very popular with porpoises. So we just have to be careful to have some understanding of how they behave in fast currents, and also fish, which are their food source ultimately, particularly fish that are up in the water column. They will be up at the same height as the blades on a tidal stream turbine will be spinning, so potentially they will be impacted by them.
So what we have here on the table next to me is one example of what a tidal turbine might look like. Each of these turbines generates electricity from the flow of water. So we're not generating energy from a height difference like you might do with a hydroelectric turbine. What we're doing is we're generating energy simply from the force of the flowing water. So anywhere you have a headland or a channel where water is constricted and it accelerates, where these fast flows are, you can generate electricity. So what happens is you get a fast flow of water towards the front of these turbines, which then rotates in the flow, and you have an electrical generator and you create electricity which is connected to the national grid.
Now, one thing that's common with all the different ways that we generate electricity from the sea is that we're taking energy out of the sea, and this means we're changing the natural environment. We need to be able to understand and predict what might happen to the sand and the shape of the seafloor if we put in things like tidal turbines to extract the energy. And the way we do this is twofold. We might go out into the environment on boats or on the beaches, we take measurements and we understand what's going on at the moment. When we've developed that understanding, the next step is to move on to predicting what might happen. And this is when we turn to computers.
We build computer models of tidal machines and other things, as well as models of the whole of the Welsh coastline, for example. But those models need testing either against field data or against experiment. This machine I'm standing next to is a flume. It gives us a recirculating water current, a controlled flow of water, which we can then use to undertake experiments which help us to validate our computer models. So I just need to put this in here. Okay, Gareth, do you want to turn that on? In the past, Wales exported coal around the world. We were a high carbon country, and now by getting involved in renewables, we are now becoming a low carbon country. And that's a really exciting thing to see that movement from where we were to where we're going. And I believe that marine energy has a part to play in that.